Get rid of this thing. Okay, some answers still coming in. We're looking at about 2/3 first timers, 1/3 returning. Still adjusting. Okay, we're going to move on. What is your job title? So you've got a couple of options here. Just pick whatever's closest. So architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. It looks like we are SREs are in the lead. Oh, an architect popping in, a couple of backend developers maybe. Okay, looks like we're majority SREs and DevOps tonight. All right, let's keep going. We've got some questions from our speakers. This first one's from Luca. Have you used Ansible for automation in your IT work before? Yes, no, or don't know what that is. So where's Luca? Okay, looks like we are getting most people saying no, but only about 2/3. Is that what you were expecting with this question? Yeah, this is about what you expect. Okay, awesome. Next question. Okay, I think this one is for Nagarachu. Is this your question? Yeah. What's your level of experience with IAC? Infrastructure as code, I assume. Yeah. So none or beginner, intermediate, or advanced. Oh, how would you define what is beginner, what's intermediate, what's advanced? Yeah. Wait. Maybe use that.
Okay. Intermediates is something you make use of open source Terraform modules or CDK constructs. Advanced is something where you create modules and contribute to Terraform open source modules or CDK constructs. Yeah.
Okay, so it's like using it versus contributing to it. Okay. I don't know if that changes people's answers. Yeah, quite a good number of people saying advanced, actually. All right. Does this also come from you? Is this also your question? Yeah. What's your level of experience with observability and monitoring? Okay, again, what do you think is intermediate and advanced here?
Intermediate is something you make use of readily available observability tools like AWS native CloudWatch or X-Ray. And if you would like to use something on your own, deploying Prometheus or Grafana on your own and manage it on your own, that would be advanced.
That's more like managed versus your own managing it yourself. Okay. Well, a lot of people are saying intermediate. Nobody's saying advanced. Very interesting. Okay, and then I think this one comes from Octavian. So after the last 5 years of cloud relevant work, my skill has improved and that I have more services to solve my problems. It's improved that I'm using the same services, but to more depth or stayed the same. So Octavian, oh, wait, there's one more here. I was worsened. I lost my patience. It was all downhill. So what are you expecting with this? Octavian, this is to you.
Yeah, well, I'm gonna build upon this.
Okay. I'm loving that there's this like it's all downhill from here. No. Okay, most people actually, like majority of people have said things have improved. Either they're using more services or services to more depth. So that's positive. That's looking up. Okay, cool. Thank you very much for contributing your questions, your answers. Oh, a selfie. Okay, I need this for social media. So just wait. I think I need people to like come in a little bit more. So maybe if you're sitting at the end, you like just go into the middle a little bit. No, just like sit in, move in the chairs inwards a bit. Not move the chairs, but sit in the seats a bit closer to the middle. Yeah, I can do that.
You need a very wide leg.
I do. I have to take 2 photos.
place and beautiful rendition of Jingle Bell. And therefore doing Christmas for everyone there and everyone listening. So, stand back, think about something. You are back there today, forward and see what's going on.
Okay, if you want to speak or you want to sponsor or you want to promote your own events, you go to cloudnativefund.com. We've now booked up for speakers until August next year, so just plan ahead if you want to speak. A bit of a plug here for sponsors in the System has finished regular sponsorship, which means that we need to find new sponsors to keep this event running. Otherwise, at some point, we're going to run out of money to pay for pizza and drinks. So if any of you work at companies that are interested in sponsoring, please get in touch with me. Okay. All right, that's it. I'm going to hand over now to Luca for our first talk. So please, round of applause for Luca. You don't need to applaud yourself. It's fine.
Thank you. Wow, I need to keep you awake now. Let me see. Welcome, everybody. My name is Luca Berton, and I'm going to talk you from zero to hero how to build the Ansible Pilot Community. So, first of all, important, everything that I'm saying here is my personal opinion and doesn't reflect the one of my employer. And now we can start. So my name is Luca. I'm an Ansible automation expert based in the UK. And as you can see, I like a lot of Helm, not the one of Kubernetes only. What I'm trying to, I will show you a small demo and how you can actually take advantage from Ansible automation technology. As I know that somebody of you already know this technology, somebody else no. I would like to show you how could be the practical impact of this. I'm also the proud creator of this Ansible Pilot Community, that is a YouTube channel, a website. So if you struggle with some error related to Ansible, more or less, sooner or later we're gonna meet each other, because I created more than 500 articles with a lot of documentation around this lovely software. It's an open source software that is actually led by the Red Hat Corporation. And if you never heard before, is an IT automation tool that is getting more like orchestration. But now let's start with the fun. It starts as like a programming language, and sometimes it's difficult to make what we would like to do it with this programming language. As you can see, there is a lot of like development in IDE, as well also a lot of terminal interaction. So somebody of you is already familiar with this type of tool, somebody else no. This is why I prepared a small demo. Let's see if I'm able to share. It's still online? Cool. So a typical execution is called like Ansible playbook. So there is some step that we would like to execute on the target machine. Target machine is usually a system that we would like to configure. And the most easy things is actually testing the connection with a ping module. This is nothing related to the network ping. It's just a way of testing the connection. Behind the scene is connecting via SSH and executing some Python code. Well, it looks like that, but probably make more sense in this way. Sorry, let me hide the video panel. Oh, I'm struggling because it's exactly on the line that I would like to type. It's annoying this. Okay, here we go. So my target machine is a Ubuntu machine that I have here on my laptop. As you can see, it's the latest version with Ubuntu 39, and it's good to go. It just have a SSH connection installed, So what I'm trying to do is executing the code that I was preparing. Need to specify the inventory file and the recipe, if you're familiar with like a Chef or Puppet, other automation tool, and we got a green light. So which means that I'm able to connect to the system. Now, I would like to complicate a little bit the things, and I was preparing something more like Kubernetes. So what I would like to do is actually installing Minikube, and I can specify a specific version, 1.13, for example. I'm running on an ARM machine, so I'm using ARM64, and I'm going to download on the /download directory on my user. Same story. Ansible inventory, and this file is called playbook YML. So what it's going to do behind the scene is downloading Minikube, verify the checksum, and try to install on the target machine. We're going to end up with an error because, well, the super user is able to execute the installation. So let me solve it out. Let me add a magic parameter that asks me the password for the user, for the sudo operation, and now we'll be able to install the Minikube. Cool, we got a success, as you can see. We got our case status, and we can verify on the target machine that Minikube version is actually the one that we would like to do it. Minikube, we are all familiar with that. It's super easy to have a Kubernetes cluster that we can interact just for fun. Okay, but now I would like to complicate a little bit the things, and especially I would like to understand better the performance implication. So how can I optimize this execution? So for this, there are some parameters in the Ansible configuration file, and this is a plugin that enables more debugging on the screen. It's called callback plugin. As you can see, there are some, so these are like some special plugin for printing out the timer for each execution. What I'm gonna do is just change the playbook to, let me change to the following version. So it will be executed again. And let me launch the execution. In this way, this time it will print it out step by step, as you can see, the timing of execution. And in this final report, we can see that it took exactly 5 seconds to execute in this machine. But there is one interesting catch. So we can break it down, the installation, the download, the verification, the checksum. So imagine if we need to do this operation like for 1 million server, this 1 second will be 1 million seconds. So doing this type of analysis could be is very interesting. And one thing that is taking 1 second for the gathering facts, this is actually acquiring some system information that we don't need for this execution. So long story short, this is one example what I'm sharing with my community on my YouTube channel. And if you are curious, you are going to find all the code in my website. So behind the scene, I had a lot of fun, and I'm trying to share with my community a lot of like example and topic, like how to install Ansible in all the possible Linux distribution. I tried also the most weird things like Gentoo, or I tried to get all and try to keep up to date as well. Also to it was more or less my journey to upskill myself and how I can learn, because every day I'm learning new things, and every day I'm trying to share with people. Because I think that if we become a better engineer, we can actually change the world. And what strange things was that I started just for sharing with some friend, and I started receiving some feedback on between people. Well, some was there was positive and negative. I try to include some of that, and it's nice to see that some errors are recurrent between different people. So why shall I waste half an hour to solve a problem while another person on the other part of the world? And it's fun because when people start send me some idea or proposal, and wow, I didn't realize that we are more connected than we think in this way. At the moment, I'm sharing my content on YouTube. I noticed that not a lot of engineers on TikTok. This I can say for sure. And also not a lot on Instagram, I would say. I have a website, and Medium is actually working better. Stack Trace, I'm not sure. I heard a lot of good intention. I don't know exactly. And these are more or less my numbers. So more than 500 videos, and I recorded, unbelievable. I recorded more than 50 hours of materials. And it takes a long time, because just for recording one video is just for 10 minutes. There is like 1 hour behind the scene, more or less, because you need to start with a script, record, re-record, not sure about the quality. You forgot to turn on the mic. So it's a lot of fun. And yes, there are more than 3,000 lines of code. You just bump in the website, and if you are lucky, I already solved the problem for you. And it's more interesting do all the engagement analysis, because a lot of people not only share the feedback, but they also communicate. There is a lot of data science behind, and I'm able to see what are like the spiky moment. Now there is this trend like event-driven automation, and it seems that people are super engaged in this way. And you can see that at least my community would like to see more code. So this is what I'm trying to do, it like let's speak more code, because okay, I'm doing a lot of this type of analysis, and more or less this is the distribution worldwide, people from especially States and India. And it's fun because it seems that things pile up. The more I learn about one technology, the more is shared. So for example, I did a series about integration between Ansible and VMware, another series about Ansible and Kubernetes, and there are different type of audience, but they give me very interesting feedback, and also some use cases that I didn't thought before. Ansible has an official newsletter. It's called Bullhorn, and it is weekly nowadays. And when I have something very remarkable, I'm sharing with them. So if you would like to be up to date on the project, I really recommend you to subscribe to this newsletter, because it's not so famous, but a lot of like changes in the project are actually found out on this Bullhorn. Do you remember the Log4Shell? I was the author of the Ansible playbook for detecting the vulnerability in a lot of different machines. So I thought that it was natural using Ansible to scan all the machines in our network. So if you take a look, that is official on the website. There is like this playbook that it does only the connection and verify that if the system is like a COVID test, is vulnerable or not vulnerable. And what else? Oh yes, I'm also attending conferences, and you are lucky enough to be here and getting a little bored. Thank you guys. And what else? Oh yes, I was just a few months ago in Berlin, and it was a lot of fun because there was an official Ansible community, and it's great that some people that we saw each other around the world, and now we call friends and we keep in touch, and sometimes we have some crazy idea together. Like I'm working with one guy and I'm writing a book, but this is a different story. because I already published 3 books about Ansible. Yeah, I'm a bit verbose like all the Italians. And I'm super proud because these are practically brand new. The first was released in December 22, so 1 year ago. The second in May and the third in July. Now I'm actually writing something else. I'm not sure if we'll be able to publish by before Christmas. It's about the Ansible automation platform. And well, it's a journey getting published. And to be honest, not very rewarding, but it's a lot of fun. So if somebody needs some advice on this journey, I will be happy to share with you, maybe later on. And well, what else? This project also allow me to connect with a lot of different community and people. You might know some of this brand. Other might be completely new. I would like to give a shout to the Ansible Lockdown. That is an incredible resource where you can find like a CIS benchmark automated with Ansible. And they are really working a lot to detect a vulnerability in our system. Another really interesting project that I'm working with is XLab, is a company in Slovenia that they are creating a tool for like keeping up to date our code in Ansible. So if you want to try, is a really interesting tool, and other companies that you might probably already know. I'm using a lot of tools. This is just a few. I just included some logos. I'm sure that a lot of people struggle to detect Audacity, the one for audio post-processing, because when you publish, especially with Pluralsight or Udemy, they would like people like to hear clear the voice. Apparently, the voice is 80% of the delivery in every, especially in this type of technical content. Okay, I learned a lot of things in doing this journey, especially, I don't know, public speaking, because for me it was totally difficult. Also how to make video post-processing, how to use all these audio interfaces, and okay, how to be here also. I like to talk with people, so I hope that there will be any opportunity to chat with all of you guys about your challenges and what you're doing in your life. For 2024, I don't know exactly what I would like to do it, but I would like to expand this project to different technology, not only Ansible. I'm thinking that Kubernetes will be very interesting technology, especially for the future, because, well, we are seeing a lot of like buzzword inside the artificial intelligence, and I think that Kubernetes will play an interesting role in the future. And I think that's all. If I'm really looking forward if you would like to follow me on my website and all my social media.
So any questions for Luca, you can either ask them in the room and have this microphone, or you can type them and on that same link before. So any questions for Luca? Okay, maybe not in the room. Oh, yeah. Cool. Is it on? Maybe not.
No problem. Oh, yeah. Thank you for sharing your experience. I think from what you shared, I hear you're really busy man, and I wonder if that's always was so, and you were just making more of that what you already knew, or at some point you just changed your careers and decided to generate more content like you do, and if that's the case, I was wondering, like, what was the driver? If you are open to share, how did that journey actually start for you?
Thank you. A really great question. So it started during the pandemic. I was bored like everybody. I was at home, and well, there's not a lot of things to do it. I was already watched all the Netflix things that I was interested. And when I started, I just say, oh, let's give it a thought. And the most pivotal moment was when I was publishing one video and 10 people watched it. But now it makes no sense, but for me it was incredible. So some people were interested on the stuff. It was a long journey because, well, the video was terrible. I wasn't able to speak. I was completely not taking pauses on explaining. And somehow it worked also on my career because I was working for Red Hat at the time in the Czech Republic. And then there was an opportunity to come here in the UK, and my actual employer take a look on what I did and say, well, of course, you know what you are doing. I don't think that I'm the best Ansible in the world, but every day I have a commitment. So I'm trying to learn something new every day, and it's incredible because this project has. It's like every open source project is a combination of a lot of different little projects underneath, and somehow it's difficult to keep track of everything. I don't know. So it seems easy from the beginning, but then when you go deep on how the connection is actually performed and how can I optimize this stuff, I was driving crazy. Like, I hope that I was not too much technical on the demo, and maybe somebody of you is curious to keep going and see how this adventure goes. I don't know. I think that as engineers, somehow we are working with a lot of interesting technology and we are really impacting the world. But sharing and communicating is a great skill also. Thank you.
I think we have a couple of questions on here. Okay, was it the hat for Red Hat Linux on the previous slide, goals 2024? I'm not sure what do you mean? What is the hat? Was it the hat? Was it a hat on the slide? Okay. Oh, was that from Red Hat? Okay. What's your view on Fedora versus Ubuntu?
Oh, yes, was my original Fedora, because each employee of Red Hat used to get the Fedora for yes, I still have it home and it's a lot of fun. What's your view on Fedora versus Ubuntu? Well, there are two wonderful distributions, and I think that they are for different use cases. But it's not like a fanboy like Apple or Google. I think that the market is big enough for everybody. Is there another question underneath?
Need this. So how can Ansible Playbook help adopt machine learning models?
Wow, good question. I think that maybe it's not playing a lot on the machine learning model, but the machine will be still need to be manageable. And managing manually is so annoying. Like I was sharing to you, installing Minikube is easy if you're doing for one machine. It's just one command, but one command when you have 10, 100, 1,000, 1 million server is a lot of manual work. So I think that the more we find a way to optimizing our workflow, so we can dedicate to save our time for really interesting activity. Thank you.
And the third one, let me scroll down a bit. Have you read Jeff Gearing's Ansible for DevOps book? Do you like it?
Yes, I really would like to meet Jeff, actually. I try to contact him in all the possible way. And I think Jeff is incredible. He's one of the person that inspired me to do this type of speak. I really like his style, and he's really improving a lot, especially on the integrated system for Raspberry Pi. It's really a front-end technology. I saw that also made a video with Mr. Beast. So it is really incredible. He created this book is one of the Bible about Ansible, and is very popular. So I think he created great content. I also tried to contact Michael Dehan, that was the original creator of Ansible, and now he's working on Ansible in Rust, the same this way. It's called Jet. So if somebody is curious, this is like a different project, and it's very promising. I tested one test preview, and it's cool. Thank you so much.
All right. Any more in the room? Otherwise, I'm going to finish up there. Please, round of applause for Luca. Okay, we're going to now welcome our second speaker of the evening. So why don't you get set up, and over to you.
Evening all. Hope you are doing well. And before starting with the actual content, I just wanted to present this quote, which is somewhat resonated within the Kubernetes community, that too when it comes to monitoring or advanced observability for Kubernetes. I mean, within Kubernetes landscape, the path to manage Kubernetes itself is complex, but when it comes to the observability, it's on another level as well. Now, this observability has posed challenges even for the experienced professionals, and this statement is the base for today's presentation and the solution which we'll be exploring within it. I'm Nagaraju. I work for AWS as a DevOps architect. I'm here to present AWS Observability Accelerator and a quick guide to deploying that Observability Accelerator with CDK. And in today's session, I would like to introduce you all to this accelerator solution. I'll explain some of the features which could be used or explored when you try. I believe just recapping on the poll we did, I believe some of, or at least 38% of you are into SRE and DevOps. And also you have used EKS and making use of the observability tools. So I feel this session will resonate with most of you. Now coming back to the agenda, I'll also present few of the patterns. Patterns is something like, again, if you make use of EKS observability within AWS, you get to use AWS native tools, or you can make use of the open source tools. We have some specific patterns among them, and you can mix and match as well. We'll go through a few of the examples. I'll cover quickly a demo as well when time permits. Now, why this solution was built? Obviously, across a lot of forums, even in our reInvent and reinforce conferences, a lot of customers approached us if there is a way to manage observability for EKS specifically, with which covers all of the foundationals or the pillars of the observability, like logs, metrics, alerts. If there is a solution which could help us to deploy it with probably a few user interactions and get ready, get on with the observing the platform. Now, some of the customers also had the opinion of we don't want to use AWS native tools like CloudWatch or X-Ray. Is there a possibility that we can make use of open source observability tools? Now, that's where we wanted to add the support for any of the managed observability tools like Amazon managed Prometheus, Amazon managed Grafana. Those are also like something what our customer asked. Now, the other ask was around codifying the setup. Obviously, a lot of DevOps and SRE teams, they don't want to do ClickOps. They don't want to go through console and integrate EKS with all the observability tools, and they want something easily deployable with the infra code tools like Terraform or CDK. So with that ask, they wanted some accelerator solution which could be they could make use of with all the best practices which AWS themselves have learned helping their customers. So with this ask, we built this observability accelerator. This is an opinionated, flexible infra as code tool. When we say opinionated, it means there are specific patterns or users which we think is the best suitable for the EKS observability. Now, this is not limited to them. Since it's an open source tool, anyone can request for additional features, and or you could even contribute to them. I'll come to that part of side, how to contribute and how to request for any new features. Now, what is AWS Observability Accelerator? It's something which helps you provision all the required tools with infra as code support. It deploys the all the basic building blocks, like the resources for observing the EKS platform. It could even deploy a EKS cluster for you and then deploy the observability tools. Or if you are bringing your own EKS cluster, it can add the necessary plumbing or scaffolding to monitor the your EKS cluster. Once it is deployed, it will also configure all the monitoring or observability solutions like Prometheus and Grafana, so that they start ingesting the data. Say, for example, if your EKS cluster is ready, and if it needs to push some of the metrics or logs, tools like Prometheus will be used for collecting all the metrics, and even logs can be collected and sent to, say, for example, CloudWatch. Once we ingest the data, there should be an option to view the results in dashboard. This is something SRE engineers are something they want to have in day-to-day operations of their clusters. So once this solution is deployed, we promote it as a single-click solution. Once you deploy it, you should be able to do this in like matter of 20 to 30 minutes. Some of the features I would like to go through, again, just on a high level. This accelerator features basic infra monitoring. Obviously, any EKS cluster, you would like to monitor the underlying infrastructure, because EKS or any Kubernetes cluster for that matter, it will be running on an infra like a VM or your own bare metal server. You would need to monitor the cluster usage, node usage, and how many pods are running, how the memory and other allocations are. So that can be done with the this monitoring. This, when you deploy, you will be able to start monitoring the underlying infrastructure. And when it comes to the application workload, currently Java and Nginx based applications are supported. Any applications making use of Java and Nginx as a web server or proxy server, those can be monitored with this solution. Recently, we have added NVIDIA GPU-based collection as well. So any cluster which makes use of GPU, that to NVIDIA, those can be monitored. So any metrics related to NVIDIA GPU can be now monitored with single click. Now, the last one, CloudWatch Container Insights. This is only supported with a CDK Observability Accelerator. We do have Terraform Observability Accelerator, but this session mostly covers one with the CDK. We try to keep them in sync in terms of the features, but currently CloudWatch Container Insights, once you make use of this Observability Accelerator, is only available through the CDK version. Now, I mentioned about the patterns. Now, lot of customers, as I mentioned, they don't want to go with AWS specific observability tools, and some of them would like to make use of the open source tools. And there are customers which they by default go to AWS native observability tools. So to accommodate everyone, we have multiple patterns. And there is another use case where, like, customers want to bring their existing cluster. They don't probably be using this accelerated solution to create the cluster. So we accommodate bringing the existing cluster as well with this solution. Or you can start with creating a new cluster along with any of the observability pattern along with it. Which means we have these many patterns available as part of this solution, where we support existing EKS cluster. You can add on any AWS native tools, or if you want to make use of only open source, then there is only open source observability pattern available. You can mix and match. Say, for example, you would like to monitor, visualize with the Grafana and send all the metrics to Prometheus with Amazon managed Prometheus or Grafana, and then send the logs to CloudWatch. So there is a mixed pattern available as well. This pattern, one of these single new EKS cluster, what you see here, hopefully, you can see the mouse tracking here. So this is just a vanilla cluster which you can deploy. This helps you to, if you want to try this solution out, you can deploy this solution and select this pattern to just deploy a empty EKS cluster, and then make use of any of the existing, starting with the existing pattern, which will help you to give a try or a demo on your own to check how these patterns are available, or on how you can deploy them. Now let's look into one of the pattern. In this pattern, as I mentioned, we do support both AWS native and managed open source observability tools. This pattern, where we can create a single new EKS cluster with open source observability added. This command line, what I'm showing here, this is the single command you would be running, and what it does under the hood is these 6 operations, and you don't need to wait for this operation to be completing. You can get on with your day, go grab a coffee, and after a few minutes you will have cluster ready with the observability related tools deployed as well. Under the hood, sorry, it deploys the open telemetry operator, which OTel, if you know, if you are into the observability or monitoring space, OTel is something, an open source managed observability solution, which helps you to deploy a single agent or a single solution, which could then feed into any of the observing solutions like third-party tools like Splunk, Datadog, CloudWatch. It can adapt to any of the destination observability solution. So that's something, it's again part of the open source community. You can make use of that and deploy to collect all the telemetry data. And FluentBit, another open source based solution to collect the logs, that gets deployed as part of this command once you run this. It also deploys ADOT collector. ADOT is something open telemetry, but it's AWS distributed version. We do make use of open source open telemetry and have our own open source distribution that again fits into EKS world rather than any other Kubernetes versions. We deploy Grafana operator along with some external secrets to manage the Grafana with its API key. And then we create Amazon managed Prometheus workspace. This workspace is where an instance of Prometheus is created for you, and that is the destination for all the metrics and alerts you could configure for the observability. We do create some of the recording alert rules by default. And then at the end, you will be able to visualize all of this data in the Grafana, Amazon managed Grafana, without manually creating any of the dashboards. For SREs, this will be the best suited option, where they just deploy the cluster and they will be able to visualize their cluster in a few minutes. Now, if you can imagine, or if you can now visualize this architecture, so if, I mean, for any of the Kubernetes users, this would be familiar. You will have an cluster, a Kubernetes cluster. In this side, obviously, it will be EKS. It runs with, I mean, once we deploy, all of these resources get deployed behind the hood. You will have a dot container, which collects all the metrics from the application container like a sidecar. And you have Fluent bit to collect the logs. A Grafana operator here, that's something CNCF open source solution. Grafana operator was created by CNCF community to deploy dashboard related resources into Kubernetes clusters and have a GitOps approach for the dashboard, something SREs make use of it, where you codify your dashboards and any changes to the repo is automatically pulled in, and your dashboards are updated in real time with the help of Flux. Now, this Grafana operator was only open source and was available to the open source Grafana version. Some of our essays worked with CNCF team and worked on the design proposal for integrating any Grafana instance, any third-party Grafana instance for that matter, including Amazon managed Grafana. With that integration, that future update, now the Grafana operator supports any third-party Grafana instances to be managed via GitOps for dashboard updates. Now, once all of these resources are in place, they start feeding into target data source systems, and then you'll be able to visualize them in Grafana. So I'll show the actual dashboard, but this is how your Grafana instance would look like once you have the solution deployed. Say like you have an empty Grafana instance. As soon as you deploy the solution, within few minutes, your cluster will be monitorable, and you could see all the data metrics getting into the Grafana. The data source will be Prometheus. Grafana pulls the data from Prometheus, and you will be able to visualize them right away. Similarly, we have CloudWatch AWS native pattern. This deploys some of the bare bones for CloudWatch-based monitoring. It does make use of some of the open source telemetry tools like ADOT and the Fluent bit for collecting the logs. This is something to integrate Kubernetes logs to be available within the CloudWatch. And then you can make use of CloudWatch and container insights to the visualization side. Architecture is pretty simple because you only have few resources to be deployed for AWS native. Now, once deployed within AWS CloudWatch, you will have your dashboards looking like this. And this is something you wouldn't see when you deploy EKS cluster, but when you deploy this observability accelerator, whether a CDK version or the Terraform version. With CDK version, you will have the container insights. With Terraform, you'll only have the default cluster-related dashboards. Yeah. Now off to live demo. I'll quickly show you something which I have already deployed, and I'll also quickly deploy one of the pattern which I've showed you so far. So just for the demo purpose, I have two Grafana instances here. So this dashboard in EU West 2 region I have deployed. It's currently active, and you can see all the data and metrics are available, and it is live. This was deployed with an existing EKS cluster with the open source observability pattern. Once deployed, these were the dashboards readily deployed with the Grafana operator, which I explained in a previous slide. It makes use of Grafana dashboards GitHub repo. Users can have their own repos as well. If you have customization for the dashboards, you can link it with the YAML files, and you would be able to deploy it as an Kubernetes resources. Once you deploy, these will be the dashboards available to visualize for you. All of the data is available in Prometheus, and that's visualized within the Grafana. Now I have another Grafana instance. This is within the EU West 1 region, where this is empty, as you can see. Now here I have an empty cluster deployed, which has only these default namespaces. Now here, what I'll do is deploy this open source observability pattern again. For this, I would need these parameters, what I'm showing on the screen. So currently, the one catch within the open source observability pattern is it doesn't create the Grafana instance for you. You need to have your own Grafana instance ready, which again, an empty Grafana instance. We are working on adding the creation of Grafana and managing through APIs part of the this observability solution, so that you don't need to even go through with creating these parameters and running them. That's something work in progress. So here, what I'm trying to do is creating some SSM parameters for Grafana API keys, which will be stored in SSM parameter. If you have used AWS, there is parameter store called System Manager, where you will create a key value pair, which could be retrieved from another programmatic source for further use case. Now I'm creating a API key param where I'm passing the Grafana API key, which have pulled in with the AWS Grafana command line. Now, once this is done, I make use of the existing. I'm not sure if you can see the screen here. So at the bottom of the terminal, you see I'm making use of existing EKS deploy. So obviously I don't want to make use of mix. This will be open source observability. So we do make use of this make command, no pun intended. So make is something like, a really a familiar open source tool within the Linux engineers or the system engineers. Make provides connecting any of other programmatic command lines. You can link them and have some dependency calculation and create a easily deployable solutions like this. So when I run these commands, it creates the CDK synth in the background, and it also then does the CDK deploy commands for me. So since I have existing cluster deployed already, which outputs following parameters, here you can see it provides the command to quickly interact with your Kubernetes cluster. So you can run this command, and then you'll be able to run the Kubernetes related commands like get namespace or get pods, whatever. And then you also have a role name, which will be used for all the cluster interaction. When you make use of the update kube config on your local, behind the hood, it will assume this role to manage any of the operations on your Kubernetes cluster. Now for our solution to be deployed, I'll just need to replace this placeholder where we provide what's the cluster name where we are deploying this observability solution to, and what's the role name it's supposed to make use of. since this gets deployed as a CloudFormation stack, CloudFormation behind the hood will be able to instruct this deployment to make use of this role for any observability related deployments. So hoping and with the support of demo cards, I'm just running this. So as I mentioned, when you have a cluster, it takes about 10 minutes to 5 to 10 minutes to deploy any of the observability tools and then get on with monitoring your cluster. If you are trying to create a new cluster, it takes about 20 minutes to deploy both the cluster and then add the observability scaffolding for that. Now, as you can see, it's doing a lot of these stuffs behind the hood. Yeah, it's too a long list to go through, but once this is deployed, idea is it should be having creating a Prometheus instance for us, creating any of the cluster resources like operator, Grafana operator, Fluent bit operator. These will be deployed with the help of CDK Blueprints. CDK Blueprints is another open source repository which makes use of deploying EKS cluster very easily without going through any of the manual intervention. And it also provides you some of the mostly used patterns. That's also available both in Terraform and the CDK version. Now, once this is deployed, I would expect our Grafana instance, the empty instance, to have some dashboards available. This is where we'll be able to see additional dashboards coming up. So meanwhile, just wanted to understand how many of you are making use of EKS and have gone through some of the pain points, what I mentioned about observability. Anyone with EKS? Yeah. Aware of EKS at least? Making use of Kubernetes clusters on AWS, anyone? I see. Not the Azure, okay. So you have AKS there, yeah. Cool. Okay, okay. That was solely for monitoring GPU workloads, is it? Okay, okay, yeah. With this accelerator, now, as I mentioned, GPU, that if you are making use of the NVIDIA GPU, that is, that observability is also readily possible. Now, this solution, what I talked through so far, it's available in GitHub. I'll share the QR code where you can go through some of the links related to this solution and the foundations like EKS blueprints. But the idea is you'll be navigated to these GitHub-based website where we go through all the features for this observability accelerator, specifically for CDK. You have similar one for Terraform as well. Now, this is the GitHub repo. Since the launch, we have seen huge engagement from our customers and users. They are making use of this solution to deploy and monitor their EKS cluster. Yeah, and if you have any future requests, you would be able to discuss within the issues here. If you'd like to go through any existing issues here, you might have some of the features in progress to be supported. Yeah, for example, there is an huge request from multiple customers in the forums about supporting the multi-cluster pattern. Currently, we are only supporting single cluster, but there are multi-cluster use cases across multiple regions. That's something we are looking into support as well. If you have anything which is not listed here, you could request as well. And obviously, since this is an open source and most of our colleagues are working on a this as a contribution. We don't have any SLAs as such. This is just like side of the desk activities for us. And similarly, contributions are welcome. Like any open source solution, we do welcome contributions to this. Yeah, now the deployment is complete. Let's see if we have the dashboards appearing here. Hopefully deploy to the right cluster. We can see some of these. They're still okay. As you can see, previously when I did the Kubernetes get namespace, there were only default namespaces. Now there are a lot of new namespaces have started appearing, including Flux, OpenTelemetry operator, and Prometheus, Grafana operator as well. I think it will take few more seconds to get the dashboards. Yeah, Grafana operator is running here. Meanwhile, any questions from anyone?
I'm not sure if this makes sense, but that's why I'm asking. Would it be possible to fetch what I would call external data, as in budgets, so the pricing information, some information from the security advisory, so this trusted agent, etc., etc. So things that are available as a services, and just to have them in, if you onboarding open source technologies like you nicely do, it would be great to be able to pull those data in Prometheus as well. I'm not sure if that's possible. Would it make sense? Any of your comments?
Yeah, sure. Really good question. I think I'll answer in two parts. For cost monitoring, there's one existing feature request which we are working on. That again, cost monitoring for this Kubernetes cluster, what you have deployed, and what are other observability tools we deploy. We would like to monitor cost for that. A lot of our customers really want to do that. So yeah, there is an existing feature request for that, and we are working on that. In terms of security and the best practices, that sounds like a new feature request, I would say. But yeah, it will be a really good use case where you would like to monitor your cluster's health from the security point of view, if I'm not wrong. Yeah, I would suggest to raise as an issue in the repo, and we'll definitely look into that. Without any timeline, but yeah, definitely. Yeah, thank you.
I saw you mentioned it, GPUs, I think, and I would like to know if what were the challenges when you try to observe clusters based in GPUs.
I've not specifically had an use case of a GPU in our cluster so far, but the immediate challenges were when it comes to monitoring with the GPUs like NVIDIA, to have interaction or the solution which could talk to GPU APIs or the drivers. With NVIDIA specifically, there were obviously some complications around how you can access them and make use of those drivers to collect all the data. It was around that one of the challenges we had. But the most of the use cases what our customers are requiring from the observability side was to look at the GPU's resource use cases, like how much memory GPU itself is consuming, or what's the usage of the GPU. So those metrics were not readily available for them. So they wanted to monitor that. And that's where one of our engineers worked on adding this support. I'm pretty much not sure, like, what extent it goes on to providing the details. That's something I can explore, or even you can explore. And if it is missing anything, you could definitely raise it as an issue. I know it won't, it doesn't answer completely, but we definitely would like to support anything if it is missing in the future. Yeah. Sorry.
Thank you. Any indicative costs of running all of this? I mean, I know it's a share of whatever you use, but it would be good to understand how much extra that would be, obviously, using CDK.
So using the CDK itself or Terraform Observability Accelerator is free of cost. Those are open source tools. But what you deploy with those, like Amazon Managed Prometheus, Amazon Managed Grafana, based on the data charges, they are pretty much standard what you can see within those services price planning. But again, as per our first question, right, I would like to have that view within these dashboards about the cost, overall cluster cost, and any of the observability tools we are using for this cluster. We would like to monitor those costs. That's something we are working on. But any use, like any of the resources costs, those are additional. Like if you make use of, as I mentioned, Managed Prometheus, Managed Grafana, they will have their own data-related pricing. That's obviously you are making use of any like any AWS service. Yeah.
Yeah. Other than the Grafana and Prometheus in terms of AWS managed parts here, in the open source section, do you have any other pipelines which can bring up the additional observability management platforms which can help? That's one of my question. Secondly, obviously this is going to be the challenge where the live logs are collected and directly sharing to the dashboards altogether. Instead of that, can we dump and realize something like how we are doing in the CLK stacks with the file beats and all this? Okay, instead of taking from a live question, I'm sorry, the live logs which can be analyzed in the Grafana part, why can't we save the data and then whenever we require, has like how we are doing in the ELK stacks? Yeah.
Yeah. Sorry, I missed the first part of the question as well. But the second one, storing the logs offline, there is a use case of where we can store the logs into S3 and then analyze them later. That's not part of any pattern as of now. But yeah, that if you have a use case like that, that's something we would be willing to support based on the traction. But yeah, it looks like the idea would be to make use of any other third-party monitoring tools as well with those offline stored logs. Like, for example, some of the clusters make use of stored logs in S3 and then feed it into the Splunk. If that's something, okay, yeah, that's currently not supported. But I don't think that's listed anywhere in the issue as well. But yeah, if you'd like to add, that would be great. If you could repeat the first part.
The first question is, other than the Amazon managed Grafana and Prometheus, is there anything the second level observability platforms is in the pipeline?
With the open telemetry operator, what we have added into the solution, that gives you an option to fit into any of the third-party data, like observability tools. As I mentioned, even Splunk, Datadog can be integrated. Even AppDynamics can be integrated. It's just that OTel needs to have that customization. If you are come across this OpenTelemetry, it provides this metadata modifier for each of the third party, meaning you deploy this one single solution and it can fit into any destination. Now, there is one challenge there, or one customization. You need to add this EMF for that specific third party. Once you configure that, it can fit into that. However, currently within our pipeline, it's only these open source tools what I mentioned. If there are any other open source observability tools which are missing, we'll be definitely happy to look into that. Yeah, I think we are near. Yeah. Okay, it's still not appearing, but I do have the alternative dashboard which I showed you earlier. Yeah, cool. Thanks for the time. Thanks for the questions as well. I'll stop here. Yes.
All right, thank you very much. We're going to take a break now. So you can go outside, pick up any drinks or food left over, come back in 10 minutes at 8 o'clock for our third talk. Thank you.
Yeah, am I audible? Okay, nice. Okay, what is up? Okay, so yeah, nice to meet you. I'm Octavian. So I'll be. I know the title doesn't make any sense. It will make sense as we go along and at the end. So basically, I want to start kind of at a higher non-technical level of principles and heuristics and rules of thumb as to what to do in a cloud environment and what not to do, and then like deep dive into specific examples and possibly services, and go at a lower, more technical level. So yeah, the usual disclaimer: views are my own, and I mean, I work for cloud for companies that have cloud, but I never worked in the cloud department, so I don't have some internal knowledge of working within a cloud department. The only experience I have is as an external user, just like everybody else, as someone trying to get various stuff done, various projects. So yeah, basically for this, I mean, I some of the ideas, if in case there are some which are good, I copied from others, and then I added some bad jokes of my own, and then that's kind of it. So yeah, the kind of the what I was asking myself when making this presentation, I guess the first thing is why? I mean, why? There's quite a bit of a delay. Huh? Okay. Anyway, so I mean, as someone attending like a conference or a talk, I mean, why would you attend a talk by some random person talking about some technical topic when you can probably ask ChatGPT a lot of these things? I mean, one reason for attending is, of course, the drinks and the socializing. But talking like content-wise, I guess what will be the reason? So just to enumerate, kind of what. Okay, sorry, there's a bit of a delay. Anyway, yeah. So basically, GPT-4. I mean, it can it suggests some high-level use cases when you, let's say, you have an architecture to design. It can give you like some options with pros and cons, and also at a lower level, it can give you like code and so on. Like, let's say you never use Postgres, it's going to give you some code how to make a database, how to query it more efficiently, and so on. But I guess more importantly than this, like, when I first used it, basically I had a chat bot that and basically the server was on my laptop, and I was thinking, how can I, like, I just wanted to, I had like 1 day deadline, and I was thinking, what's like the form in which I can deploy it so the backend serves the chatbot, and then it told me of some proxy service that basically gives a public IP and just connects to my server. And I realized, wow, okay, I had no idea about this. Like, you know, I just used the best cloud, which is no cloud. I just did it from my laptop. So that was quite helpful. So I mean, in very dire contrast, I don't remember anything from my AWS Architect certification. I mean, I remember things, but not because of the certification, because I did projects with them, but purely because of the certification, probably close to zero. So then, yeah. So then, like, how can a human be more useful in the context of such presentation? So for that, yeah, we can just think of a simplified mental model of what LLMs are, and that's basically like some probabilistic like a probabilistic machine, which just basically starts from something like the cat and then weighs what is next, and then like compares probabilities, and there's some randomness, so it doesn't always do the same thing. Of course, it gets more complicated than this, but basically it's a comparison of probabilities. Yeah. So like in contrast, what is different, or like a different model from this, can be exemplified a bit by darts, which I mean, I don't know how to play it, but I've been told that by some people who know how to play it, is that experts don't aim for the bullseye; they aim for the higher corner because there's a higher density of points there. So basically, in this case, experts know where to have bias, where to aim for. So building upon this example, an expert knows where to limit the error rate and where to have bias, and where like they can overshoot. So for instance, let's say a good trader, always limits their losses, gets out of positions fast to prevent significant losses, cascading losses. So basically, I'm similar to this. I want to think of some heuristics, some rules of thumb that can be useful, where someone can suggest some asymmetry, where to have bias. So now to explain what the title actually means. So there's like two ways of learning, like through addition or through subtraction. Like through addition is like, I don't know, the AWS, like some cloud certification, like these are the services. And through subtraction is like, you realize one service doesn't work well, so you're not going to use it. Or you realize you do things and then you realize that was a mistake, and then you don't do them. So like, for example, yeah, so AWS is like something that is that removes. So basically, you can iterate on some business idea without having a data center, and without much upfront cost. Well, something is like clicking on my, yeah, interesting. Anyway, so yeah, it is in a way something that takes away. So I failed in several businesses, but in a very short amount of time and with very low cost because of being able to iterate with this. And something opposite is actually I made these slides like a few months ago, and at the time VR was quite in vogue, but at the moment I'm not hearing much about it. So maybe I realized maybe some people already forgot a little bit about it, or is in the back of their minds. But at the time, it was a lot more talked about. So this is an example of Via Positiva, something that adds. So this is, so I'm presenting this as a bias towards Via Negativa, towards like a removal of pain as opposed to giving of, let's say, features or anything. Another example, if we look at services, would be basically serverless. Like you don't need a server, so you don't need to manage a server. So opposite is like basically, let's say, a service that is solving a problem that is already solved by other services. But to be honest, this is one service that I thought was in this situation like a few years ago when I looked into it, but maybe now it's improved. So like another kind of like heuristic things don't necessarily have to make logical sense. It's enough that they like survive the test of time. Like you can see here, this is, I think, a kitchen from 2000 years ago, still the same utensils. So basically, their usage was useful because they survived the test of time, not through some logical reasoning. So to illustrate this specifically in tech is, so if you think about 2015, when the pound was quite powerful and prices were lower and other stuff didn't happen. So that was when I had my first permanent job, and at the time there was this language that was in vogue, which was Scala. Basically, it sorts out all the problems. So, like for instance, like it's immutable, so it sorts out concurrency, which of course it doesn't, because concurrency comes from like a fundamental mismatch of reads and writes. It cannot be solved at a higher level. Anyway, it's more concise, runs on the JVM. So I mean, why would you not use it? So I started working in this, and I mean, it was the thing to do. It was growing exponentially, going to the moon. And nowadays, I looked for it to see where it is in terms of most used languages, and I couldn't find it. Like I looked on some, I couldn't. I looked on some website of top most used languages, and then it wasn't on the first page. So I kept looking, and it was. So I'm kind of highlighting here that. So Pascal is when I was 14 and started doing like small level programming competitions. Pascal was the language that was supposed to go away because it's so old, and it was supposed to be replaced by C and so on, as part of like, and even that, sorry, and even that is above Scala now. So yeah, I mean, that was kind of the end of the story. So yeah, what this illustrates, that like test of time is more important than logic, can be more important than logic in certain situations, is that like the Lindy effect, which is that information is works in opposite ways to like the human lifespan, where the more it has existed, the more it has to, the more it can continue. So, I mean, okay, this is not really necessary, but this is kind of the definition. So basically, you have a probability distribution, and if you shift it, then the tail becomes even more important. So that's information. That's not humans. Humans are the opposite. So yeah, to actually illustrate this, I guess, so an application of this would be like, using the basic components that existed for a very long time, as opposed to using something that is more recent. However, I saw in the poll that I guess quite a few people disagree. So I'm interested in the debate at the end, maybe. And this can be applied in other parts of life. What succeeded test of time is probably more. Another example is when I was working at some point for a company that's providing cloud, and you have the like kind of continuous debate in a project, like should we use function as a service, should we use containers? Function as a service, like it's easier to start up, but then maybe I'm cheap, maybe I don't want to have a separate database, maybe I just want to have it in the same machine so I don't pay more money. So then maybe I want to use containers, but then containers don't really solve all my problems. So it's always this debate. And then at the time, there was this new idea that was the best of both worlds, that is both serverless and where you have more control as to the configuration of your environment. And that was supposed to, be the future where I should have put my applications in my future applications, and it would become public at some point. And then I'm still waiting. Huh? Sorry, there's. Okay, so I'm still waiting for the solution to be public, but haven't seen it yet. I'm having a synchronicity issue here right now. Okay, so yeah, this is and other examples of like killers of something that is very well established. They appear and then they disappear. So it's another kind of test of time. So I'm doing I'm doing debugging of an asynchronous system as I'm presenting it. Okay. So another thing here, another kind of example that I was thinking about is always, when I don't know if this is still the case. I think it must be, because it was always when I was doing like some applications, is that like I would be in a meeting and then someone would say, let's use X because it works on both iOS and Android. And then a few months later, in another meeting with other people with same application, someone would say, let's use Y because it works on both iOS and Android. And I had this with React and with Vue, and then other things were proposed as well. And actually here, I'm a bit on shakier grounds because I don't know much about Terraform. I tried using it for 1 or 2 days. But the example I'm trying to give is that like I always used CloudFormation for configuring projects on AWS. At some point, I also had something on Google Cloud. And I was thinking like, okay, maybe I should use Terraform because people say, you can just move the infrastructure. You just click on a button, you go on any other cloud providers, click on a button, it's going to download everything, and then you deploy it on the other cloud provider. It's just amazing, So you can optimize for cost, you can optimize for everything. You just don't like one, you move to the other. So yeah, so I mean, okay, okay. So basically, the problem after I did that one click is that from Google Cloud, and then there's a lot of Google here. So how am I deploying this to AWS? I can't. There is a missing abstraction layer. Of course, I don't know. Maybe like a Terraform expert is going to come and say, okay, this is all wrong. But from what I saw, I think it is quite difficult because of missing abstraction layers. Also, yeah. So I started. Oh, okay. Sorry, I'm gonna just put everything back in. Okay. Yeah. So yeah. So I downloaded everything with one click, and then there was nesting. Like various parts of the projects were nested in folders, and they couldn't reference each other. And then at that point, I just tried to use ChatGPT. I was just in a rush. I don't really care. I just want to get it working. And GPT said, yeah, you should use TerraGrunt. Okay, and I used TerraGrunt, and then I had like other errors. Not solving the previous file cross-folder referencing errors. And then he suggested some other solution. And then I just gave up. So, and then I gave up, and that was the end of Terraform for me. So I guess, I mean, one problem that some of these so-called zero-cost abstractions might have that I think of is that like they are a particular software that for which no one gets paged in case of some important feature doesn't work. No one wakes up in the middle of the night, as opposed to pretty much anything in a cloud, any used feature. So I guess yeah, these are all the, like, I mean, these are the asymmetries I can think of. And yeah, so they okay. I'm gonna do the this is I'm starting to get curious now. What kind of issue it is? Is it just delayed or? Okay. Anyway. Yeah. Okay. Anyway, so I guess this is yeah, this is the end. So yeah. So I mean, as I saw, there were opposite points of view in the quiz, and yeah, I'm curious, like, if there's any kind of debate on this, or if people have other better ideas to suggest. So yeah, that's it. Thank you.
Okay, any questions for Octavian in the room? Or
I guess it's more of a comment, isn't it? I'll try and make it into a question. So what you've said, I totally identify with it. It reminds me of, you know, there was a product called RightScale. Do you remember RightScale? And their whole pitch was, they came along and said, so you shouldn't be using proprietary cloud. You should be using an abstraction layer, and our proprietary product will give you that. And it's sort of like, okay, an abstraction layer has a value, but if it's another proprietary thing, then it doesn't really achieve what it's setting out to achieve, right? The fact is, if you did stuff in RightScale, whenever it was 10 years ago, it's now less valuable than if you did it natively in AWS, right? So so it didn't really set out to achieve what it was going to achieve. So I think, I guess the moral is, we need to be really careful about abstraction layers, especially when they come with a commercial price tag, because they might be solving a problem that either doesn't exist or they can't really solve. Is that fair?
Yeah, I mean, I don't know the specific example. Sounds like something very familiar, but with just other naming, like a very familiar problem I faced with, just other naming a situation. So.
yeah, I don't think that's on. So
I got something that will relate to what Paul said, but first you mentioned asking questions to GPT for the context of getting information on new tools and such. I think I asked similar questions to GPT version 3, but in a slightly different context, where I asked for specifically an open source tool that will do A, B, and ideally C. And it gave me 3 answers, all of which were wrong. They were either not doing what I wanted to do, or they were not open source. And I briefly mentioned this to someone who works on language models in AI, and he said that that's because those models work on probabilities. So when it is convinced enough that it's a good enough answer, it gives you the answer as a fact, while it's factually wrong, which is a clear black and white kind of question. So that is my personal view on why I wouldn't rely on any tool, and I'd rather come and discuss these things in person in an event. But also, going back to the previous point, abstraction between different clouds, something I probably heard in another meetup was that if you are using cloud or multiple clouds with the idea of having a unified view of the cloud and being able to move from cloud A to cloud B, then you're not doing cloud. You're just using it as a virtual machine or database hosting environment. You shouldn't be in the cloud. You should be using the cloud if you're really leveraging the services a particular cloud provider is providing. If you're locking yourself into that provider, then you're doing the cloud right. So if we are basing our view on this approach, then we shouldn't be even asking the question, how can I have an abstraction layer? Because that shouldn't be the question. We should be looking at the problem as, why do we even need an abstraction? Why do we not happily lock ourselves into the environment? And then we will have a different view, and we wouldn't be looking into things like a Terraform module that can create service accounts across different providers, or some abstraction layer, open source or proprietary, that will abstract it. This is my view. This is not so much of a question, but rather raising a few points to get your view on them.
I'll just add to that. You've always got to ask the bean counters what abstraction layer they use to avoid lock into Microsoft Excel. Just ask them, because they don't have them. Because why would you?
Yeah, I mean, I don't know your particular use case makes sense. I mean, for one of my most frequent use cases, which is to spend less money while doing the same things, I sometimes wanted to move from one cloud to another just to spend less money. But I mean, like, I'm just, someone working on some small projects, let's say. So I mean, I guess like, yeah, I guess like it's a thing of scale. So I guess what you're saying makes sense.
Thank you very much. Another round of applause, please, for Toby. All right, that wraps us up not only for tonight, but for 2023. Woo! So have a fantastic Christmas, New Year. We will see you again on the 10th of January. So note, it's not the first Wednesday because that's too close to New Year. It's the second Wednesday next time. On your way out, please return these lanyards to the basket as you go out. And if you want to hang out further, the Conductor is the pub downstairs that we will be going to afterwards. Thank you very, very much for coming out tonight. See you next year.